If you look up at the sky today, you see commercial airplanes leaving long white stripes. But here is the specific observation. It is visibly worse today than it was a couple of decades ago. Today, these stripes don't just fade away. They spread out, they linger for hours, they grow into massive cloud banks, and they even cast distinct dark shadows. This is a new, worsening phenomenon.
Exactly. And by starting there, we are engaging in the very first step of the scientific method, observation. We are noticing a physical change in our environment. Too often, people who point this out are lectured or brushed off by the general consensus. But in strict science, an anomalous observation is the most valuable thing you can have. You don't mock it, you investigate it.
Right. So let's look at it with completely fresh eyes. Here is the second observation. A jet releases roughly 1 liter of water for every liter of fuel it burns. From horizon to horizon, you can see maybe 200 kilometers of sky, and crossing all of it, a jet burns 600 to 800 liters of fuel. So the water it actually leaves above you is less than 1 single ton. Now the cloud that grows out of those stripes, spread just 2 kilometers wide and half a kilometer thick along that same stretch, that is 200 billion cubic meters of cloud. And even at the thinnest ice density found in cirrus clouds, that is 2,000 tons of ice. 1 ton went in, 2,000 tons are hanging there. The plane physically cannot have carried that cloud. More than 99% of it was already up there, in visible moisture, waiting. The plane only supplied the trigger.
Spot on, which naturally moves us to the second step of the scientific method, forming a hypothesis. If the mass of the resulting cloud is vastly greater than the mass the plane can physically carry, then the plane is not depositing the cloud itself. Our hypothesis must be that the airplane is depositing a catalyst.
A binding ingredient.
Precisely. In atmospheric physics, this is related to something called the Schmidt-Appelman criterion. The ambient water vapor already present in the upper atmosphere needs a nucleation point, a microscopic physical surface to cling to, condense, and freeze around. So your observation proves that the exhaust cannot merely be just harmless water vapor. There has to be a physical residue, an ingredient left behind by the turbine that binds the ambient moisture together into a persistent cloud.
So let's look at hypothesis 1. New additives are causing this. We need to talk about SAF, sustainable aviation fuels. The idea is simple. Because these fuels are made from waste and plants that recently pulled their carbon out of the air, burning them is counted as adding almost no new CO2, so airlines can report far lower emissions without changing a single engine. To force this, the EU enacted the Refuel EU aviation mandate, legally requiring suppliers to blend SAF into jet fuel, starting at 2% this year and rising to 70% by 2050. But when I actually read the EU's own technical reports, my jaw dropped. I literally had to double-check that this was real.
It's one of those things where the truth is wilder than the conspiracy theories. What did you find?
The media makes it sound like some high-tech, clean synthetic fuel, but the EU's own aviation agency reports what is actually going into the tanks, and the words on the page are used cooking oil and animal fats, categories 1 and 2, which is the legal definition of slaughterhouse waste, including diseased animals. Waste. They are legally blending processed waste into the fuel and spraying the residue across the sky. And when you break down that SAF, it is not high-tech at all. 98% of it is simply biofuel. Only about 2% is the genuinely synthetic, lab-made e-fuel that the marketing loves to show. 98% is just processed biological waste.
And that biofuel? Break it down further. 81% is processed used cooking oil, degraded seed oils like canola, sunflower, soybean, and palm. 17% is those category 1 and 2 animal fats, the slaughterhouse waste. And the last couple of percent is other food waste oils. That is the real recipe.
And because Europe can't produce nearly enough of this waste, they import most of it, which makes it incredibly hard to control what is actually in it batch to batch.
So where does all this imported waste come from? The watchdog Transport and Environment found that 80% of Europe's used cooking oil is now imported, and the majority of that comes from China. And here is the problem. Demand is now so high that cheap virgin palm oil is suspected of being relabeled as used cooking oil to cash in, fraud that is almost impossible to detect once it is in the barrel.
So, step back. If they are pouring imported, burned seed oils and slaughterhouse waste into the fuel, can that really burn cleanly? Can the exhaust really just be harmless water vapor, like the consensus insists? Or is this dirty, unregulated mix exactly the kind of residue, the catalyst, that would seed these worsening stripes?
That is a brilliant hypothesis. But here is where science gets messy, because when we test it against the hard data, we hit a contradiction. There's a massive joint research campaign called the ECLF3 study, run by the German Aerospace Center, Airbus, and Rolls-Royce. When they burned SAF in midair and measured it, they found the exact opposite of what we'd expect: 56% fewer contrail ice crystals than regular jet fuel.
But hold on, did they test the actual dirty, mixed waste that gets pumped into everyday airplanes, or a hyper-refined sample for the cameras?
That is exactly the catch. The fuel in the ECLIF3 test was a 100% pure synthetic blend called HEFA SPK, lab grade. It is not the messy, cheaper slaughterhouse and seed oil mix that airlines will be forced to burn en masse. So let's be clear on where Hypothesis 1 stands. Waste-filled SAF might be worsening the stripes, and we cannot rule it out because the exact waste mix changes from batch to batch and import to import. We just can't confirm it from a test that used the clean stuff.
But there is an incredible admission buried in that same study that we can confirm. To get a baseline, they had to measure regular jet fuel too, and they state it plainly. The soot from ordinary jet fuel acts as a condensation nucleus, and the water vapor freezes onto it to form the ice crystals. They measured it.
Exactly. They proved the foundation of your hypothesis. Airplanes are seeding clouds with soot.
Okay, so hypothesis 1 is concerning but unconfirmed. Let's look at an entirely different option. Hypothesis 2, airplanes are flying higher. I was reading an August 2024 study from Imperial College London, led by Dr. Edward Gricebeard, published in Environmental Research Letters. They analyzed over 64,000 contrails from satellite data using machine learning, and their findings are wild.
What exactly did they find?
First, they confirmed our initial observation. Modern planes really are causing a new kind of stripe that lingers far longer. Here is the mechanism. To burn less fuel, modern jets are designed to cruise higher, around 40,000 feet, where the air is thinner. But that puts their soot straight into a colder, ice-saturated layer of the atmosphere.
Right. That freezing air is holding more moisture than it can bear. So the instant the soot hits it, the vapor crystallizes around it into massive, long-lasting ice clouds. But what was the wild part?
The climate impact. These lingering artificial clouds trap heat trying to escape the Earth and radiate it back down. And the study found the warming from these new persistent contrails is actually greater than the warming from all the CO2 the efficient engines save. It may even be greater than the warming from all the CO2 that aviation has emitted since the invention of the airplane. By flying higher to save fuel, they created a blanket of warming clouds.
So the planes got more efficient, climbed into freezing air, and their soot started forming permanent clouds. It's a solid, scientifically proven hypothesis.
And there is promising news on how to fix it. In 2021, the German Aerospace Center and Eurocontrol ran real-world trials. They diverted planes up or down by just 2,000 feet when entering zones prone to contrail formation. Then they checked with satellite images and confirmed that this tiny altitude change made the long-lasting stripes much less frequent.
That's huge. 'Cause flying higher, solution, just shift altitude when you hit those zones. It sounds like the puzzle is solved.
It sounds like it, right? But in science, you keep your eyes open. And I noticed a contradicting observation. I was driving past Munich airport, and the sky directly around it was massively polluted with thick, lingering stripes. But planes taking off and landing aren't cruising at 35,000 feet.
No, they're at very low altitudes near an airport, which means flying higher into freezing air cannot be the only reason these stripes form.
Exactly. The flying higher hypothesis is brilliant and confirmed, but it does not explain the stripes right above the airport, so the puzzle isn't fully solved.
Which is exactly how science works. An anomaly always leads to the next question.
Let's recap our scientific journey. We started with the observation that the stripes are getting worse. We proved that a cloud's water can't fit in a tank, so something must be seeding it.
Then, Hypothesis 1, the unsettling reality that the EU is blending imported waste, burned seed oils, and slaughterhouse fats into our fuel. Concerning, but not confirmed as the main cause.
And Hypothesis 2, Imperial College confirmed that higher flying planes leave worse stripes that drive real warming, and altering altitude by 2,000 feet can stop them. But the airport observation shows there's still a missing piece.
Science is an ongoing process. We followed the physics, we challenged the consensus, and we uncovered some massive truths along the way.
That is the power of the scientific method. Look up, ask questions, and don't be afraid to follow the data wherever it leads.